everyone, Uncle Jesse here. Today we're going to be doing a follow-up to my last video where we were comparing the slicing times between Chitubox, Lychee, and Pikaslice. And so many of you commented that you didn't care too much about how long it took to actually slice the files, but you were more interested in if there were any actual print deviations between the three slicers. So that's exactly what we're going to be doing today. We're going to be taking the exact same set of files and running them across each of the three slicers, comparing print times as well as the print results. The files that we're going to be using come from Loot Studios. They're pre-supported and hollowed, which should help eliminate any differences between laying out these files across the different slicers, just because we're not going to have to hollow and support them in each of those individual slicers. Trying to make this as apples to apples a comparison as possible. And I'm going to try and use the exact same settings across each of the slicers. We're also going to be running two sets of tests for each of the slicers, one with anti-aliasing enabled and one disabled. And I want to take a minute to say thank you to today's video sponsor, which is none other than Elegoo, the makers of the Elegoo Mars 3 that we're going to be using in today's video. And we're going to be cleaning all of the prints over on the Elegoo Mercury X Wash and Cure bundle. And we're going to be printing all of the busts for today's prints on the Elegoo Saturn II, which was just recently released by Elegoo and is a fantastic mid-size resin 3D printer that prints in some beautiful details. If you're interested in more information about any of Elegoo's products, you'll find links to those down below. So I primarily use my M1 MacBook Pro for slicing all of my files, so I wanted to run back through and I'm going to reslice all of the files and time out again how long it takes to slice each of these files. And the first one that we're going to be taking a look at here is Chitubox, which took just over 1 minute to slice and took 4 hours and 24 minutes to print these set of files. And the files with no anti-aliasing took 55 seconds to slice and 4 hours and 7 minutes to print. Now let's take a look at the files from Lychee Slicer. And the files on Lychee took 1 minute and 6 seconds to slice and exactly 4 hours to 3D print, so saving a total of 24 minutes compared to Chitubox. Which is honestly kind of surprising. I would have really thought that all of these prints with the exact same settings would have printed the exact same time. And the files without anti-aliasing took 1 minute and 3 seconds to slice, so again, slightly quicker than Chitubox when it came to actually printing. Now let's take a look at Pikaslice, which again is a slicer designed for your iPad. Currently only available on iOS devices. Hopefully at one point here will make its way over to Android as well, because this works really well. But also to this really cool tip here where I brought in these files from Loot Studios and they just were not slicing correctly. And there is an option here under the support menus there called Separate Shells. And if you go through each object and run the separate mesh function, it will then slice properly. So if you're running into any weirdness with your files when trying to slice them, try and use that operation. Now this is where things get a little bit crazy, not because I knew Pikaslice was going to slice faster than all of the other slicers, just because, again, it's an app developed for an iOS device, which has its own dedicated processing and all that other good stuff that typically is related to running apps themselves on something like an iPad, but because the print times were a good bit quicker coming from Pikaslice than the other two slicers. The file with anti-aliasing enabled took 3 hours and 44 minutes to print. And then the one without anti-aliasing took 3 hours and 41 minutes to print. So let me get my notes here just to make sure that I've got everything correctly stated, and I'll have them up here on screen just for your viewing pleasure. I'll also make sure to share this detailed spreadsheet with you all as well if anyone's interested in comparing these things. But comparing Chitubox to Lychee, there was a 24-minute print time difference between Lychee and Chitubox, which is, in my opinion, pretty substantial with the anti-aliasing factor enabled. Now, where things get a little bit crazier is with Pikaslice comparing to the other slicers. So Pikaslice compared to Lychee was a 16-minute difference in print time. So again, Pikaslice was able to print faster than the already fast Lychee sliced print compared to, again, Chitubox. And comparing Pikaslice to Chitubox, it was a 40-minute time difference, which is a substantial time savings. Again, exact same settings, same printer, same files, only difference, the slicer. But what I really wanted to do was actually dig in further and find out exactly what's the difference between these files. Is there like a setting that I missed? What exactly is off that's allowing Lychee and Pikaslice to print so much faster than Chitubox? So in order to compare the CTB files, I needed to actually find out what data was inside them, extract it, and then run a compare against each of them. So I downloaded and installed UV Tools, which is an open source application that has been developed and shared, available for Mac, PCs, on Linux, you name it, it's going to run with it. And it allows you to analyze your sliced files, and it's got a whole bunch of different things that it's going to run through it. But what I was excited about is that it was able to analyze these files that have been generated for the Chitu-based board 3D printers. So after running each of the files through UV Tools, I was able to extract the data and put it in a spreadsheet here that I'll put up on screen. Again, we'll be sharing links to this if you want to dig in and provide some more details on this. But it was pretty interesting to see some of the differences between the actual sliced files. So anything in red on the spreadsheet is going to be what's different between the others. Here, the very first thing that you're going to notice on Lychee, which I thought was odd, is that the Z height is different than the other two slicers. So you're losing 5 millimeters there. That's probably should be looked into and confirmed if it's 75 or 70. But the primary settings that we're going to be looking into are the ones that are going to drive the overall print time, like the exposure settings, the lift settings, etc. So we can see with Pikaslice, it wasn't exactly 2 seconds for the exposure time. It was actually slightly, like by a fraction, longer than the others. But I think the one set of settings that are making Pikaslice print faster than Lychee and Chitubox is coming down to the lift speed settings. So we have the retract speed and the lift speed, which are slightly faster for the lift speed, but actually slightly slower for the retract speed. And I'm not sure if those offset each other because one is +2 and one is -2 compared to the other slicers. So I'm not quite sure how that impacted the overall print times for each of those. But I did have that set correctly in the slicer. It's calculating it here off ever so slightly. Another interesting one is under the Lychee slicer, there is a rest time after retract, and then the bottom retract speeds were set to 0, which after going back in and looking at Lychee, am I missing it? Where are those settings? I can't see more to see where to actually set those. But outside of that, nothing else is majorly jumping out as a difference between specifically Lychee and Pikaslice compared to the Chitubox slice files as to why those printed substantially faster than Chitubox. You could be looking at a real big time savings by looking at Lychee slicer over Chitubox or Pikaslice over Chitubox, especially for those mid-size to larger resin 3D printers like the Elegoo Jupiter that are going to allow you to print insanely tall. Those time savings are going to really add up. And what's so odd to me is the sliced file information is almost identical, but for some reason Lychee and Pikaslice are printing a good bit faster than Chitubox. Again, I'll be sharing the files here, so if you wanted to dig in and take a look at those, go at it. Now let's take a look at the biggest factor in all of this, which is print quality. Is there any difference between the prints across all 3 of these slicers? Can you spot the difference between each of these prints? If I didn't have them labeled, there's 0 chance I'd be able to identify which came from which slicer. So at an initial glance, I really can't tell the difference between which of these prints came off of which slicer, even if it had anti-aliasing enabled or disabled. And I think that just goes to show how well the Mars 3 prints, as well as how great these files are from Loot Studios. But if I take a very close look at the prints, in a few key areas, we can really start spotting the differences between the quality of these prints. As a side note, I also do not recommend Gorilla Super Glue for gluing your prints together. It's leaving some white residue on the resin prints. Yeah, definitely not using this anymore. And I also, right before filming this, dropped one of the prints there and broke the buzzsaw. But taking a quick look at the prints with anti-aliasing enabled, if we really focus in on the side of the helmet there, or the head of this character, we can see some of the layer lines forming, and they're very faint because anti-aliasing is enabled, but I think it's definitely more distinctive on the Lychee and the Pikaslice files versus the Chitubox. Surprisingly, the Chitubox files look the cleanest out of all of these. But again, I've got to really get in there to see those details. And if we compare the prints that have anti-aliasing disabled, you can again really spot the differences between those, and the Chitubox version is really faint. And it almost looks like it, even though it has it disabled, it's still somewhat enabled. It's very, very faint compared to Pikaslice and the Lychee prints. Now, I'm gonna have a hard time telling you exactly which of the slicers is best or which you should use over the other, because there are other factors involved with this when it comes to things like actual doing supports and hollowing and all the other functions that are involved with these slicers. It's not just as simple as loading in a file, hitting slice, and then running off and printing your files, unfortunately. But what I can tell you is that the results that I've seen here today, regardless of which slicer you're gonna use, you're gonna get fantastic prints. That's the bottom line. It's all gonna come down to how concerned are you with things like slicing time as well as print time. I'm definitely gonna be looking at running some more tests on this, and I highly advise that you don't take my word for it. Run off and run these same tests for yourself and try it out. Even just comparing Chitubox to Lychee with the same prints and the exact same settings, and see if there's any print time differences on your end, because I'm definitely interested in hearing from you on that. And again, I'll have links to the spreadsheet with all the test data that I had here down below. I also want to say a big thank you to all of my Patreon supporters for your continued support. If you're interested in all my different Resin 3 printer settings, you can find those over in my Patreon. But again, this was a really fun one, and I'm glad you all pushed me to go in a little bit deeper on the actual print comparisons here, not just the slice times, but also the print times and the actual print quality that we're seeing here. Hey, thanks so much for watching, you all, and I'll see you next time. Bye now.